So, in Indifference and Repetition, Deleuze writes that, and I quote, "We must move to a geometry of sufficient reason." But, and he uses this notion, a geometry of sufficient reason, he uses it again a little later. But Deleuze, as usual, is kind of a bastard here because he just drops this idea and he doesn't explain it at all, as if it is perfectly clear, which it is not. So I want to ask, what is a geometry of sufficient reason? This is actually the question that I try to answer in my book. However, instead of turning this question into a study on Deleuze and his concept of geometry or his concept of sufficient reason, I took this idea and I turned it into a broader historiographical idea. In other words, I found that this notion can help us see some overlooked connections in the history of philosophy. Namely, this geometry of sufficient reason connects 17th century rationalism with 20th century continental philosophy. So, as I tried to show, the first roots of this idea are found in the rationalism of Spinoza and Leibniz. Their philosophy is founded on certain metaphysical principles, namely the principle of sufficient reason and the principle of identity of indiscernibles. And when these principles are applied to the theory of space, they result in a fierce critique of the Cartesian and the Newtonian conception of space. But 3 centuries later, a very similar critique was developed, supported by very similar metaphysical principles, was taken up by Bergson, Whitehead, and Deleuze. So this is, in broad terms, the conceptual story that my book tells. The book contains 10 chapters. Each one of these chapters gives a close examination of the ideas of one of these authors. However, in the presentation today, I want to focus on the main idea connecting these authors. So I want to compensate for Deleuze's obscurity, and I want to try and explain in clear terms, hopefully, what this geometry of sufficient reason is that I have traced in the work of these authors. Now, the first part of this phrase is more or less clear. It is a geometry, a theory of space. But what is the role of the principle of sufficient reason in the theory of space? I will start with explaining the general idea of sufficient reason, and then when we turn to space, it will become clear what effect this principle has in our theory of space. So, in general, human knowledge leaves a lot of things without sufficient reason. It leaves them unexplained. First and foremost, this has to do with differences and distinctions that human knowledge acknowledges but cannot explain. In short, concrete reality is always infinitely more fine-grained than our conceptual or intellectual representation of it. The concepts with which we know the world always remain on the level of generality. When we try to conceptually grasp this dog, for example, human reason never reaches the individual. We can increasingly specify our concepts, but we will never reach the individual dog. So our theory of the world leaves the diversity and the particularity of things unexplained. Of course, we can refer to individuals through individual names, but this is not knowledge, because names are not concepts. They do not explain anything. Now, Spinoza and Leibniz are rationalists. They believe that reason can know everything. Therefore, they demand that reason and concepts go all the way to the individual. However, I'm not so much interested in this as a theory of knowledge. Instead, rationalism interests me as a metaphysical theory. So, rationalism is first and foremost the epistemological theory that knowledge is founded on reason rather than experience. But this presupposes a metaphysical idea that reality is fully determined in such a way that reason can fully explain reality. So, as Deleuze says, this leads to a kind of metaphysical delirium. In short, rationalism leads to a demand that in metaphysics we sufficiently explain for diversity, we sufficiently explain diversity and the individuality of things. Individuality needs to be accounted for. And it is this demand that unites Spinoza and Leibniz with the philosophy of difference and process found in Bergson, Whitehead, and Deleuze. Therefore, it is this demand for a metaphysical explanation for individuality and diversity that constitutes the first step towards a geometry of sufficient reason. Now, to see what this entails, we have to understand that traditional Platonic Aristotelian metaphysics cannot really explain individuality. That is, it cannot explain what distinguishes me from all other things. This is because of what I call the restrictive notion of essence. Traditionally conceived, a thing is defined by restricting it to a set of core properties. According to Aristotle, the answer to the question, what am I, lies in my form or my essence, which consists, in the case of humans, in rationality. This is what distinguishes me from animals and objects and other things, but it doesn't distinguish me from other humans, of course. But following more common sense conception of essence, I would probably define myself with some more properties. And this would distinguish me from most other things, but again, not from all of them. For such a definition is still restrictive. It limits down the individual to a set of core properties. In such a restrictive definition, we take some properties to belong to my inner nature or definition, while other properties are like the number of mangoes that I ate in my life or my relation to Napoleon, they are deemed non-essential. They are left out. By restricting our definition of something to such a limited set of properties, we are stuck with a universal or general definition. Such definitions allow us to recognize things as belonging to a certain category, but as Spinoza says, this is not knowledge. True knowledge, Spinoza says, requires proper definitions, and proper definitions, he says, are genetic definitions. A genetic definition does not recognize or categorize a thing. Instead, a genetic definition explains how a thing is produced. Or better still, a genetic definition produces a thing in thought. But of course, I cannot be produced out of this limited set of properties. The production of me implies all my concrete details. As Spinoza says, a genetic definition is such that it implies all my properties. All those properties can be derived from my genetic definition. In other words, such a definition has a completeness that a common definition by restrictive essence lacks. Now, as Leibniz argues, you need all my properties to distinguish me from all other things. It is only when we explain everything about something that we can grasp its individuality. For once you leave out one single detail, you would have two possible versions of me, and my essence or definition would be general and shared by two possible entities. So a definition needs to be complete to grasp the individuality of something. But of course, a complete explanation is an infinite explanation. As Leibniz writes, only someone who is capable of grasping the infinite could know the principle of individuation of a given thing. This arises from the influence, properly understood, that all the things in the universe have on one another. So, individuality implies an infinity of details that determine that thing to be that specific thing. As Deleuze says, Spinoza and Leibniz have an infinitist conception of the individual. Now, as Leibniz says here, the infinite determination constituting the principle of individuation of something, he says it arises from the influence properly understood that all the things in the universe have on one another. So both Spinoza and Leibniz seek this infinite explanation of things in their relation to the rest of the universe. As Spinoza says, each thing is determined to be what it is by an infinite chain of causes. Or as Leibniz says, each thing is marked by every other thing. In short, a complete explanation of me must include the mangoes that I ate in Peru and what Napoleon did 200 years ago and every other thing in the universe. And it is here that we begin to see the first signs of a reconception of space. For The traditional idea of essence, that is the idea of a restrictive essence, the idea that you can define something by delineating it or limiting it, this corresponds in the theory of space to the idea of the location of things as restricted, delineated areas. It is the idea that I am here and only here because my relation to you and my relation to the mangoes in Peru and to Napoleon are not included in what I am. In other words, the restrictive conception of essence corresponds to the restrictive conception of location. If things are self-sufficient substances, limited to themselves, the locations of these substances, the spaces that they occupy, are likewise separated from each other. Space then consists of separated locations outside of each other. This is what Whitehead calls the idea of simple location. It's the idea that you can pinpoint every object to a definite limited area and space. Now, when Spinoza and Leibniz say that each thing is defined by every other thing, this entails that, as Leibniz says, our nature extends everywhere. As I am defined by Napoleon and the mangoes in Peru, they are included in what I am. But what this means for our theory of space is that, as Whitehead says, in a certain sense, everything is everywhere at all times. Each thing is ubiquitous, omnipresent. This is the central idea of the first part of my book. And this idea of ubiquity transforms the idea of space. Space can no longer be a set of separated locations positioned next to each other. Instead, each location is everywhere. Or better, as Whitehead says, every volume mirrors in itself every other volume in space. This ubiquity of each thing and the ubiquity of each location is the first element of a geometry of sufficient reason. But more is needed. There is another more fundamental flaw in the traditional conception of space, another lack of reason. Leibniz gives an example of this in his correspondence with Samuel Clarke, who is a friend of Newton and a proponent of the Newtonian theory of space. For Newton, space is absolute. This means space is like an empty box. And things can occupy this box, but the box itself remains indifferent to and independent from the things that occupy it. This means that you can remove the things from the box, but the box itself remains unchanged, unaffected. This is a very popular and very intuitive way to understand space, but if space is this box that is itself empty, if space is this emptiness waiting to be filled, it must be qualitatively homogeneous. Space itself, empty space, must be uniform and undifferentiated. But here, the traditional Newtonian conception of space runs into problems. Leibniz argues, given this uniformity of space, there is no reason why, for example, the world is created here and not a bit more to the right. If space is homogeneous, the difference between here and here is not a real difference. For these locations in themselves are empty as spaces. But then the location of the world, the location of each thing, it lacks reason. It is left unexplained, or better, location itself, the difference between locations and therefore space itself, it lacks reason. And the problem here is very similar to the problem regarding general concepts. If concepts or definitions remain general and can be applied to multiple things, we cannot explain the difference between the things that share a concept. An absolute or empty space is similar to such a general concept. It is a space that is common to the different individuals that occupy it. It is a shared public space in which each location is open to everyone to occupy it. So just as a general concept can be applied to multiple things. So the inability of absolute space to explain spatial difference is closely related to the inability of general concepts to explain the diversity of things. But not only are these problems closely related, their solutions are too. As we have just learned, relations to the rest of the world, explain the individuality of things. They provide a sufficient reason for the individuality of things. In short, relations individualize. But what does this mean for the idea of space and location? Well, if we follow this idea that relations individualize, if we follow it to the end of its consequences, we find that relations themselves are individual. All relations are individual relations, and this is a very powerful idea that transforms our conception of space. The idea of individual relations is specifically found in the work of Leibniz and Whitehead, but I will focus on Leibniz as it is a bit easier to explain. Leibniz gives an example. Take two people, David and Solomon, father and son. We would commonly say that they have a father-son relation, but we would thus conceive their relation to be a general kind of relation, shared by all fathers and sons. For example, these two. But such a general relation, shared by all fathers and sons, is of course an abstraction, for each father-son relation is unique. Most people would accept this. But Leibniz takes it a step further. He says, even one relation shared by both David and Solomon is an abstraction. For David's relation to Solomon is something different than Solomon's relation to David. This is because Solomon relates to David from his unique position in the universe. You cannot separate Solomon's relation to David from his relation to his mother, his girlfriend, and by extension, every other thing in the universe, including the mangoes that I ate in Peru. In fact, as we have seen, what makes Solomon Solomon is this unique relation to all other things. This relation to all other things is its principle of sufficient reason. Therefore, the relation to David is part of its individual nature. And this counts for each thing. Each thing has its own individual relations to all other things. But what does this mean for space? Well, this also applies to spatial relations. As Leibniz explains, the idea of empty space, as Newton understood it, and as we most commonly understand space, entails the idea that space is a collection of empty locations. But the idea of empty places is an abstraction, for this idea entails that we understand locations to be open for everyone to occupy. Things can thus take up each other's places, and the places are indifferent to whoever occupies them. But this idea that, for example, something can take up Solomon's location, it presupposes that it takes over all of Solomon's spatial relations to all other things in the universe. But this is impossible, because those relations are individual to Solomon. As we have seen, they constitute Solomon's individual nature. Therefore, nothing can take over Solomon's location without becoming Solomon. And this ultimately constitutes what I call the immanence of space. Space is not independent from or external to the things that exist in it. Space is not this empty box that exists in itself and is independent from the things that occupy it. No, instead, space consists of the individual spatial relations that things have. Therefore, when there are no things, there is no space. Space is always full. Each location is always occupied. Or better, each location is an individual location anchored in the individual nature of its occupant. Real space, actual space, is entangled in the fabric of this infinitely differentiated concrete world. Space is always and at each location individualized. Each location of space is part of the individual nature of the thing that exists there, and thus unique to the thing that exists there. In other words, the principle of sufficient reason entails that there cannot be such a thing as public space. There is no space shared by and open to everyone, because such a space cannot be real for the very same reason that the general concept cannot refer to real thing. Such a public space, indifferent to whoever fills it, is a uniform space, lacking complete determination. And just as a general concept does not correspond to something real, but is something abstract and merely something that merely exists in thought, just like that, the public empty space shared by all things is something merely abstract and ideal. And just as general concepts need additional determination to become something concrete and to become something real, this public space, this empty space, it needs more determination. It needs an infinity of determination to become something concrete, something existing. Again, it needs to be individualized. So a concrete space, a space of complete determination, is fully differentiated and individualized at each point. But this, of course, has enormous consequences for our broader metaphysical picture of the world. For example, it entails that in metaphysical strictness, things cannot move around in space. Instead, each movement is actually a process of change, a change in nature. So in immanent space, you can only move by transforming yourself. In Leibniz and Whitehead's conception of space, you can only move by changing your point of view on the universe. However, given their relational conception of the nature of things, this amounts to changing your nature, changing your inner nature. In other words, as spatial relations define the inner nature of a thing, things change when they move. And this idea can also be found in the work of Bergson. He argues that real movement is rather the transference of a state than of a thing. Movement is not the transference of a thing from point A to point B, but rather the transference of the state of that thing from state A to state B. As Bergson writes, we should therefore reject the idea that something can change place without changing form. Movement is always a change of form rather than a change of location. And then finally, we come to the idea of quantity, which is a central element of geometry. Space, as it is commonly understood, is quantitative. It allows a more and less, and it can be measured. But the traditional idea of quantity, the traditional idea of more and less, is again founded on abstraction. That means the traditional idea of quantity, it lacks sufficient reason. Spinoza gives an example to explain how numbering things, which is a form of quantification, entails homogenization and abstraction. He says, if I have 4 coins and I count them as 4 coins, I abstract away from the fact that these are different kinds of coins. I homogenize them. And in other words, I consider them as 4 times the same thing in order to count them. But even if I only have €1 coins and I count them as 4 €1 coins, I still abstract away from the individual difference distinguishing each coin, and I thus consider them again as a repetition of the same. The problem is that the difference between these coins is then without sufficient reason. As Deleuze would say, a repetition still needs a difference. In other words, for this to be 4 coins and not just 1 coin, there needs to be a difference distinguishing each coin. They cannot be completely the same. So there still needs to be some difference distinguishing this €1 coin from this €1 coin. And traditionally, this remaining difference is what is called a numerical difference. It is the difference that distinguishes this 1 coin from this 1 coin. But this pure numerical difference is itself unexplained. It is left without a reason when all these coins are homogenized and understood under the same concept. In other words, the numbering of things cannot explain the very difference that makes this 4 coins and not just 1 coin. This difference distinguishing the coins, it needs a reason, it needs an explanation. Numerical difference needs to be backed up by a difference that is well-grounded, well-explained. Now, I have until now talked about numbers, but quantity in general is plagued by this problem. Quantitative difference, just like numerical difference, is an empty difference. It is a difference distinguishing what is qualitatively identical. It is, as Leibniz would say, a difference without diversity. And this is why this traditional form of quantity cannot exist in concrete reality. The issue here is again the same as the one plaguing the general concepts and empty space. Just like general concepts and empty space, this traditional idea of quantity, it does not have enough difference, enough diversity to really exist. And the deeper reason for this problem plaguing quantity is the so-called principle of identity of indiscernibles. This is a principle championed by Leibniz, but it can be found in each one of these 5 philosophers discussed in my book. The principle states that what is indiscernible is also identical. So in simple terms, as Leibniz says, there is no perfect similarity anywhere in the world. What this means is that nothing can be distinguished in any way without there being a real qualitative difference. So this means that pure spatial or pure numerical or purely quantitative difference cannot exist. So you cannot have one and the same thing in 2 numerical instances, or you cannot have one and the same thing at 2 different locations, or you cannot have one and the same thing in 2 different magnitudes. For then we would be distinguishing what is indiscernible, what is indistinguishable. And we would distinguish the identical. And our distinction would thus be without sufficient reason. But does this mean that quantity is a complete illusion? Does this mean that there is nothing in reality that corresponds to more and less, small and large? Well, I think there is. And part of the challenge of developing a geometry of sufficient reason is grasping the quantitative nature of reality without abstracting away from the diversity and the concreteness of reality. Therefore, we need a new concept of quantity. And the most important property of this new concept of quantity is that each quantity is unique and irreducible. Quantity is then not a more and less of the same. Instead, the more and less has effects. It changes and alters the nature of the thing. Just like the change of location changes a thing, the change of magnitude of something changes that thing. A bigger Napoleon, for example, is something different than a smaller Napoleon. Again, as Bergson says, this new idea of quantity is a magnitude which we cannot change without changing the nature of the thing. But this completely changes our idea of quantity. For example, the idea of measure must then be dropped. Quantities are measured by reducing them to different numbers of the same units of measurement. But this presupposes the homogeneity of quantity. The idea of numbering, as we have seen, and therefore the idea of numbering units of measurements, it requires that we consider them as repetitions of the same. Measure presupposes that 2 quantities have the same nature but are just different numbers of the same units of measurement. But if each quantity is unique, if each quantity is irreducible, this reduction to units of measurements cannot be done. But the question then is, can we still speak of quantity? Is there a form of quantity that cannot be measured? Well, an idea that I found in both Spinoza, Leibniz, Bergson, and Deleuze is the idea of ordinal quantity. The idea of ordinal quantity is most easily understood through the distinction between ordinal and cardinal numbers. Cardinal numbers are numbers like we most commonly understand them. Numbers then have the meaning of amounts. And as amounts, cardinal numbers include each other. For example, 2 includes 1 2 times. That is, the amount 2 includes the amount 1 2 times. But an ordinal number, on the contrary, is a position rather than an amount. But the ordinal number 2, for example, is the second position in an order or structure rather than an amount. But the position, of course, does not include another position. A position cannot be reduced to a sum of smaller positions. Therefore, the ordinal number 2 cannot be reduced to 2 times the ordinal number 1. Now, when we apply this idea of ordinal number to quantity, we get the idea of ordinal quantity. We get the idea that quantity, the more and less, the small and large, refers to positions rather than measurements or amounts. This means that quantities can be ranked in an order from small to large, but they cannot be divided into units of measurement. Again, the quantities are positions rather than measurable amounts. And what is crucial here to note is that only the idea of quantity as an amount or as a measure requires homogenization. As we have seen, when we understand more and less, or small and large in terms of measurements and numbers, this quantitative difference must be a difference between what is qualitatively homogeneous. For without this qualitative homogeneity, we cannot count things nor measure them. But order, on the contrary, order does not require homogeneity. Positions, as we have seen, are irreducible to each other. Therefore, the difference of order, the difference of position, the difference distinguishing ordinal quantities is a real difference. It is not an idle, non-explained difference like numerical difference. Instead, it's a well-founded, well-explained, it's a real difference between diverse things. So by this idea of ordinal quantity, things can be quantitative without giving up on their diversity. And better still, the very reality of quantity is thus saved. As we have just said, traditional quantity is without sufficient reason. It implies an unexplainable difference between what is considered identical. The difference between more and less cannot be sufficiently explained if the more and less are uniform. But this ordinal quantity, this quantitative difference, with the ordinal quantity, the quantitative difference is a real difference. It is a difference that is explained. It is a difference with sufficient reason. Why? Well, because these quantities are positions in an order of structure. But such positions are structural elements defined by their relations of orders, such as before and after, or up and under. But as we have seen, relations individualize. So each ordinal quantity is individualized by its unique position in the structure of the world. Therefore, in contrast to difference of amount, this ordinal difference between positions has more metaphysical foundation, more sufficient reason. So ordinal quantity is a well-founded, concrete form of quantity. It is a quantitative difference that is entangled in the individual difference between things. So let me try and conclude. One of my main contentions is that Spinoza and Leibniz rationalism, that it reverberates in the work of Bergson, Whitehead, and Deleuze. In fact, I believe there is a form of rationalism to be found in each one of these authors. However, of course, the rationalism of Bergson, Whitehead, and Deleuze is not the same as Spinoza and Leibniz rationalism. For example, the idea of an omnipotent intellect is mostly left behind. In general, the epistemological meaning of rationalism is mostly lost in these 20th century authors. But what does live on, though, are the two main metaphysical principles, the principle of sufficient reason and the closely associated principle of identity of indiscernibles. In other words, what Bergson, Whitehead, and Deleuze inherit from Spinoza and Leibniz is the demand that in metaphysics things are sufficiently determined. More specifically, it is the demand that the individuality and the heterogeneity of reality is metaphysically accounted for. And this shared metaphysical rationalism is the implicit backdrop of my book. So the deficiency of traditional conceptions of space and quantity, they ultimately amount to a lack of sufficient reason. Newton's empty absolute space or Descartes' uniform plenum, they cannot really exist because they lack the diversity to explain the spatial differences from which they are, of which they consist. So, in short, just as universal concepts, these traditional forms of space and quantity are not metaphysically robust enough to really exist. So the alternative theory of space and quantity presented in my book can be summarized as a search for the sufficient foundations for space and quantity, or the sufficient metaphysical explanation of spatial and quantitative diversity. But if we take a step back, we can ask the question, where does sufficient explanation come from? Well, I believe that in general, explanation comes from conceptual connection. So when is some idea of a philosopher well explained? Well, a notion is well explained if it is linked to other ideas and concepts. In short, it is the integration into a broader conceptual theory that provides reason. As we have seen, in the traditional Newtonian theory of space, there are things that are left unexplained. There are brute facts. And so the very difference between locations, as we have seen, is insufficiently explained. It is a brute fact. Now, when I say that explanation ultimately derives from conceptual connection, this means that the brute, unexplained facts in the traditional form of space are ultimately caused by the conceptual isolation of space in these traditional theories. The lack of sufficient reason in the traditional conception of space derives from the fact that the metaphysical connections are overlooked between space and things like essence, power, individuality, difference, relations. So this means that there are some different options to explain space and let space explain. That is, there are different ways to integrate space in a broader metaphysical theory. First of all, we could say that there is insufficient reason for the spatial relations that we have as long as they do not belong to who we are. So Leibniz and Whitehead's solution for this lack of sufficient reason in the traditional form of space, their solution lies in integrating space into a theory of essence, into the nature of things. Spatial relations does belong to and are proper parts of our essence. Another option is that space can be connected to the idea of power and force. And this is an approach found in Spinoza and Deleuze, but also Leibniz. And finally, another option is that space is straightforwardly linked to the notion of difference itself. Space can be explained as an expression of the very difference that is foundational for all of reality. And this approach is primarily Deleuze's. But what all these philosophers share is that they seek explanation of things and of space in structure and relations. So just as philosophical concepts find explanation in integration in a broader conceptual system, things themselves find explanation for their concrete individuality and their concrete determination in the relations that they have with other things. Therefore, relations are a fundamental explanatory tool. This geometry of sufficient reason finds explanation in structure and relations. As we have seen, structure and relations individualize things. The geometry of sufficient reason therefore uses structure and relations as a source of differentiation to understand the spatiality and the quantitative character of reality without abstracting away from the real diversity in the world. So both space and quantity are ultimately explained in terms of positions, individualized and differentiated by their relations to other positions. In sum, and I will end here, The geometry of sufficient reason found in the work of these authors largely amounts to a form of structuralism. Thank you.